What if I said to you that the Big Bang might not have been the beginning after all? Hang in there, because what scientists found in 2025 is about to totally transform everything you believed you knew about the origin of existence itself. At this exact moment, right now, ancient light from the universe's birth is flowing over you. Light that has journeyed for more than 13 billion years, holding secrets about a moment so deep, so enigmatic, that it questions the very idea of time itself. And here's what keeps me awake at night. We might have been posing the wrong question all along. If you're fascinated by the enigma of what preceded the Big Bang and wish to view more brain-twisting cosmic tales, hit that like button hard and signal to the universe that you're tuned in. Each click supports keeping the quest for the unknown going strong. Did anything exist prior to the universe? Ponder that for a moment. Before space, before time, before everything, was there anything, or is the query itself pointless? And more crucially, why are scientists now uncovering evidence that implies the Big Bang could have been merely one occurrence in an endless sequence of cosmic renewals? Yeah, the classic narrative unfolds like this. 13.8 billion years ago, everything, and I truly mean everything, space, time, matter, energy, all of it erupted into being from a single point of infinite density. An incredibly hot, dense condition that blasted outward, cooling and spreading into the immense cosmos we observe today. Time zero, the start. Case shut. But wait a second, because that's where it starts getting strange. In just 1 second following this cosmic blast, the universe was a seething soup of particles so scorching that nothing could stick together. Within minutes, the initial light chemical elements started to emerge. But here's the snag, and this is vital. The early universe was so extraordinarily hot and dense that light itself couldn't break free. Photons were endlessly scattered by free electrons, confined in an opaque mist that permeated all of space. For the first few 100,000 years, the universe was basically sightless, a cosmic jail where light couldn't move more than a minuscule fraction of an inch before being absorbed and re-emitted. And now picture this. 380,000 years later, the universe has been growing, cooling, and then in an instant that would resonate through eternity, something remarkable occurs. The temperature falls just sufficiently for electrons to combine with atomic nuclei. Atoms develop, and abruptly, like someone flipping on the lights in a dim room, the mist clears. The light surges across the cosmos for the first time. That ancient light remains here right now all around us, elongated by billions of years of cosmic growth into what we term the cosmic microwave background. We can actually observe a baby snapshot of the universe when it was merely 380,000 years old. And here's what's going to stun you. We can still view it. We can still quantify it. And it's revealing things that shouldn't be feasible. In March of 2025, researchers revealed the most precise images of this ancient light ever obtained. 5 times the clarity of anything we'd witnessed before. The sharpest infant portraits of our universe displaying not just where things were, but how they were shifting. The peaks and troughs in the spread of primordial matter that would ultimately collapse under gravity to create galaxies, stars, planets, us. Okay. But there's something odd in these images, something that doesn't quite match. Because when scientists examined this light, they found that ordinary matter, everything we can see and touch, stars, planets, our bodies, constitutes only about 5% of the universe. 5%. The remainder, 27%, is something known as dark matter, unseen except via its gravitational impacts. And 68% is dark energy, an enigmatic force that appears to be driving the universe apart. 2 invisible elements that we know exist solely because of their effects, but that we've never directly sensed. Now you might be pondering, okay, that's peculiar. But what does this relate to what came before the Big Bang? You know, everything. Because the further we delve into the universe's early days, the more we encounter things that shouldn't be present. Let me guide you to the cosmic dawn, the instant when the first stars sparked. According to our theories, after the mist dissipated and the cosmic microwave background was freed, the universe entered what scientists label the Dark Ages. No stars were there yet, just clouds of hydrogen and helium floating through space. Then, somewhere between 100 and 200 million years after the Big Bang, the first enormous stars erupted into being, lighting up the cosmos for the first time. We should scarcely be able to glimpse this period. The light from these initial galaxies has been traveling for so long that it's been extended, redshifted into infrared wavelengths hidden from our eyes. But in 2021, we launched something incredible. The James Webb Space Telescope, constructed specifically to seize this ancient infrared radiance. And what it discovered astonished everyone. Galaxies. Massive, luminous galaxies. Not just a handful, but more than we ever anticipated, existing just a few 100 million years after the Big Bang. One galaxy found in 2025 and playfully named MOMS 14 was glowing brightly when the universe was only 2% of its current age, just 280 million years after the alleged beginning. Here's why that's an issue. These galaxies are too large, too bright, too well shaped for their age. According to our models of how gravity operates, how matter aggregates, these formations shouldn't have had time to develop yet. It's like discovering a fully mature oak tree in a forest that was seeded last week. Something isn't aligning, and it becomes even odder. Fast forward billions of years. Matter in the universe under gravity's sway has assembled into a vast cosmic web. Galaxies aren't haphazardly distributed. They form filaments and sheets with huge voids among them. This arrangement can be linked directly back to those tiny variations we see in the cosmic microwave background. The peaks and troughs I mentioned earlier, they expanded into the largest structures in the universe. Now, according to the cosmological principle, a foundation of modern cosmology, the universe should be approximately the same everywhere when you zoom out sufficiently. Homogeneous. No area should be vastly different from any other. And our theories forecast that the largest structures that can possibly form should be around 1 billion light years across. So when astronomers in 2024 found something called the Big Ring spanning 1.3 billion light years in diameter with a circumference of 4 billion light years, they had a problem. Big problem because this structure, along with another called the Giant Arc, stretching 3.3 billion light years, simply shouldn't exist. They're too vast, too structured, too organized. And here's the kicker. Detailed analysis indicates the Big Ring might not even be a ring. It might be a spiral, a corkscrew shape twisting through space. If you could somehow see it with the naked eye, it would appear 15 times wider than the full moon. They're cosmic anomalies that challenge everything we think we know about how the universe formed and evolved. And they're compelling scientists to pose a radical question. What if these megastructures are echoes of something that occurred before the Big Bang? Now hang in there, because this is where things get truly fascinating. And one of the most brilliant minds in physics, Sir Roger Penrose, suggested something extraordinary. He proposes that our Big Bang wasn't a beginning at all, but a transition. In his model called conformal cyclic cosmology, the universe undergoes infinite cycles. Each universe expands, ages, and eventually reaches a state so empty and diffuse that it mathematically resembles the conditions of a new Big Bang, and boom, a new cycle starts. If this is true, then structures like the Big Ring might be gravitational imprints from the previous universe, cosmic fossils that endure. Penrose even claims to have discovered circular patterns in the cosmic microwave background that could be evidence of this. Okay, now most scientists are skeptical, very skeptical. But the fact that we're even having this discussion tells you something profound. The Big Bang model, despite its huge success, is incomplete, and the problems keep accumulating. Remember dark energy, that mysterious force comprising 68% of the universe. For decades, we assumed it was constant, unchanging, propelling the universe to expand faster and faster forever. We even gave it a name in our equations, the cosmological constant. But in 2025, data from an instrument called DESI, the Dark Energy Spectroscopic Instrument, dropped a bombshell. After surveying millions of galaxies and quasars, scientists found evidence that dark energy might be weakening over time, not constant, evolving, decaying. Think about what this implies. If dark energy is getting weaker, the universe's acceleration might eventually slow down. It might even halt. Gravity could regain control. Instead of expanding forever into a cold, dark, empty state, the universe could slow, stop, and begin contracting, a big crunch. And if that happens, could it spark another Big Bang? Another cycle? Yeah, we're standing at the brink of a cliff, gazing into the deepest mystery in all of science. Now let me present you with an even more radical concept. What if there wasn't one Big Bang, but many, not cycles, but bursts? In 2025, a physicist named Dr. Richard Liu proposed something that sounds like science fiction, but is rooted in serious mathematics. Instead of one singular explosive beginning, followed by continuous expansion, what if the universe experienced multiple mini-bangs, transient singularities that emerged, flooded the universe with matter and energy, and then vanished? That these bursts would occur so rarely and so quickly that we'd never observe them directly, but their impact would be profound. Each burst would seed new structures, generate fluctuations in matter distribution, and initiate periods of accelerated expansion. In this model, dark matter and dark energy aren't mysterious substances filling the universe. They're effects of these temporary creation events. It's a stunning proposal because it revives an old idea, the steady-state universe where matter is continuously created, but does it in a way that doesn't violate the laws of physics. These singularities appear and disappear so fast that they exist in a kind of quantum loophole. If Liu is right, we might find evidence in subtle discontinuities in how distant galaxies are distributed, tiny jumps that don't fit the smooth expansion we expect, fossil imprints of ancient burst events hidden in the data, and yet here's what keeps me returning to the fundamental question. Maybe, just maybe, the question itself is flawed. What if time didn't exist before the Big Bang? What if asking what came before is like asking what's north of the North Pole? A meaningless question, because the concept of before requires time, and time itself might have been created in that first instant. For decades, this was the standard view. General relativity tells us that at t equals 0, our equations break down. Infinite density, infinite temperature, a singularity where the laws of physics stop working. So we simply couldn't discuss before. But quantum mechanics, the physics of the very small, suggests something else. Some theories of quantum gravity, like loop quantum cosmology, propose that the Big Bang might have been a big bounce. A previous universe collapsed down to an incredibly small but not infinite size, and then quantum effects caused it to rebound, exploding outward into our universe. Okay. In these models, time continues through the bounce. There was a before, a pre-bounce universe of which we might find traces in our current cosmos. And now, with the DESI results indicating that dark energy might be changing, we can envision a future scenario. Billions upon billions of years from now, if dark energy continues to weaken, if it eventually reverses, our universe could begin contracting. Galaxies would draw closer together. Stars would fill the sky. Eventually, everything would collapse back into an incredibly dense state. A big crunch, and then maybe another bounce, another universe, another cycle of creation and destruction playing out across infinite time. It's humbling, isn't it? We live in a universe that's 13.8 billion years old, but we can only see back to when it was 380,000 years old. That's 0.003% of its history, hidden behind an impenetrable wall of fog. And what came before that moment, before time zero, might be forever out of our grasp. Or might it? The evidence we're collecting today suggests that the boundary between before and after the Big Bang isn't as firm as we once believed. The cosmic microwave background, those massive early galaxies that shouldn't exist, the megastructures that violate our theories, the evolving nature of dark energy, all of these are cracks in the standard model, hints that something deeper is happening. Scientists are now seriously exploring the possibility that our universe is one of many connected through time, or that the Big Bang was a transition, not a creation, that somewhere in the data we're gathering right now, there are subtle signatures of a reality that existed before. Future observations might uncover patterns in the cosmic microwave background that can only be explained by a previous cosmic cycle. We might discover fossil imprints of those fleeting burst events Liu proposes. Or perhaps one day, a new unified theory of quantum gravity will allow us to calculate what existed in that moment, before the moment, to peer behind the curtain of the Big Bang itself. What strikes me most about this journey is how much we've learned and how much we still don't know. We've mapped the infant universe in extraordinary detail. We've discovered galaxies shining when the cosmos was barely 2% of its current age. We've found structures so large, they challenge our fundamental assumptions. We've measured the universe's expansion and discovered it's accelerating. We've even found hints that this acceleration might be changing. But the deepest question remains unanswered. What was before the Big Bang? Did time begin with that first moment, Or does it extend infinitely backward through cycles of creation and destruction? Are we living in the only universe or one of countless iterations? Was there a first Big Bang, or have there always been bangs, bounces, bursts stretching back through eternity? These questions sit at the very frontier of human knowledge, where empirical data becomes scarce and imagination collides with rigorous mathematics, where philosophy meets physics, where science brushes up against the limits of what we can possibly know. And yet we keep pushing, keep observing, keep questioning, because that's what we do. We're curious creatures living in a curious universe, compelled to ask why and how and what if, even when the answers might be beyond our reach. The cosmic microwave background is still washing over you right now, ancient light from the birth of everything you know, and somewhere in that light, encoded in its subtle temperature variations and polarization patterns, might be the answer. A whisper from before the beginning, a message from a previous universe. Or perhaps just the confirmation that some questions, no matter how profound, have no answer because they exist outside the bounds of time and space and logic itself. But I don't think that will stop us from looking, because maybe, just maybe, the next observation, the next telescope, the next brilliant theory will crack the case wide open, and we'll finally understand not just how the universe began, but what, if anything, came before. Which scenario do you find most plausible? An eternal cycle of universes bouncing through time, multiple burst events creating matter from quantum fluctuations, or perhaps time itself beginning with the Big Bang, making the question of before meaningless. The answer might be hiding in data we've already collected, waiting for the right mind to see the pattern. Or it might remain forever beyond the cosmic horizon, a mystery that defines the limits of human understanding. Either way, the search continues, and that perhaps is the most beautiful thing of all. Don't stop here. The universe is full of secrets waiting to be uncovered. Click on the next video and join us as we explore even more astonishing mysteries from the farthest reaches of